Okay, so this is an interesting problem because we've got two square roots here. But again, follow the basic, your basic strategy. The inside is almost always what u needs to be. And if you do that, even though it's, seems like it wouldn't lead you anywhere, notice that when you get the derivative of square root of x, that's 1. So where did that 2 come from? 1 over 2 square root of x dx. Well, hey, look at that. The square root of x on du is on the bottom, and that's where it is originally in the problem. The only thing missing is this 2 here. So, that's wonderful. So if you put the 2 out here on the bottom inside, then on the outside you would have to put it on top. And so, this is great. Not bad at all. So here we have, now don't forget, I'm going to do it the second way with the limits of integration. I'm going to swap them on the fly. So here, when x is equal to 1, u is going to equal to square root of 1 or 1. When x is equal to 4, u is going to equal to square root of 4 or 2. See, now I don't have to worry about going back to x's anymore. I just leave everything as u's. So then I'm going to have cosine of square root of x, that's u, and then du. Okay. So then I have 2, the antiderivative of cosine is sine of u. And see, now you don't have to go back to x's because you already switched these from x values to u values. And so then all you have is 2 sine of 2 minus 2 sine of 1. And this we can't calculate exactly, so we'll just leave it like that. Okay, so it's time. We're going to get into the really, really heady ones. Integration by substitution. Notice that our rules do not apply anymore because, our instincts tell us, well, let's let u equal 1 plus x to the 4th. But then du would equal to 4x to the 3rd dx. And this you don't have in here. You have an x, but you can't just multiply by x squared and then divide by x squared. You just can't do that. You can't take variables on the outside of the integral. Not allowed. Not allowed and not okay. Okay, so we get rid of that. We go, okay, that's not good. Let's get rid of all of that. So this is obviously not the correct choice. So it doesn't look like there's anything else. I mean, if you look at this, that's all you could do. Okay, but you do notice, maybe not right now, but after seeing enough of these, you would. You kind of remember in the back of your mind, hey, when you get the derivative of inverse tangent, that equals to 1 over 1 plus x squared, and that kind of looks like that. The problem is that this one is x to the 4th, and it needs to be x squared. Well, what if I turn this into, figure out a way to get this to equal u squared? What would u have to equal to? X squared, right? So if u is equal to x squared, then this is equal to 1 plus u squared, and it looks like that. Well, you might be thinking, well, how do you get rid of the x? Aha, you get rid of right here. Because du then, if u is x squared, du is 2x dx. Whoa, that's crazy. So that means that all you need to do is you need to multiply by 2 here, multiply by 1/2 on the outside, and what you have is this right here. This is du, and 1 plus u squared on the bottom. So this is equal to 1/2 the integral of 1 over 1 plus u squared du. Wow, that was nuts. That is nuts. That's one of the nutty ones. So this is equal to 1/2 times the antiderivative of 1 over 1 plus u squared. Well, that's just arctangent of u plus c. And so then in the end, it's 1/2 inverse tangent of x squared plus c. And that's it. See, that wasn't that bad. Okay, how about another one? How about we've got the integral of x squared over the square root of 1 minus x dx. This one is definitely a challenge. Definitely a challenge for sure. Because you might be thinking, maybe, I don't know. Might be thinking, well, if it's kind of like the one we just did, I know that the derivative of inverse sine, that's 1 over the square root of 1 minus x squared. But that's not an x squared, and it's just an x, so you might think, well, what if we let u be square root of x, and then that would be x squared. But then du would have to be in there, and so, that doesn't work. So this, in this one, it's kind of like you're just jumping straight in. You just go, okay, well, let's say u be 1 minus x, because I have no idea what to do. And so then du would be equal to negative 1 dx. And so, this is kind of okay, because you go, well, I just need a negative 1 here, and then I can put a negative 1 on the outside. So this is equal to du. And then this part right here is equal to u, but your problem is you have this x squared here that, how do you deal with that? That's extra. You can't have x's and u's in the integral. So you might erase everything, but can you think of another way to convert x's into u's? Look around, look around, look around. Hint, hint. If u is equal to 1 minus x, then doesn't that mean that x is equal to 1 minus u? So then doesn't x squared equal to 1 minus u squared? So can you not plug in 1 minus u squared in for that? The answer is a resounding ding, 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 ding. Oh, I should have done it with this color. Yes. Made it with a bright yellow. Okay. Yes. Okay, so that means that this is equal to negative the integral of 1 minus u squared over square root of u. I'll leave it as square root of u. du. And so, although this one is kind of ugly, it's, involves a little bit of algebra. Not as bad as what it was. It looked impossible before. This, the best way to do this one would be to expand this one. And that would be 1 minus 2u plus u squared. And then, well, I'll do the whole thing. Over square root of u. And then let's bring the negative sign inside. And so then this would be equal to negative, well, the integral, negative 1, and then plus 2u, and then minus u squared. And then to do this, I would just put the square root of u on each one of these. Ooh. Sorry, forgot the du there. Du here. Okay, so then this is equal to the integral of negative u to the minus 1/2 plus 2u to the positive 1/2 if I simplify, and then minus u to the positive 3/2. I'm going to run out of room here. So this is minus 2u to the 1/2, and then plus 2, well, this is going to be u to the 3/2, and then times 2/3, so this is going to be 4/3, minus u to the 5/2, so this is going to be times 2/5. And in the end, each one of these u's would have to switch to the original, which was 1 minus x. So this is negative 2, 1 minus x. You're going to make me write the whole thing, aren't you? Okay. Plus 4/3, 1 minus x to the 3/2, and then minus 2/5, 1 minus x to the 5/2. Whew. Breathe. Breathe, breathe, breathe. That's it. Okay, so this one is again a tricky one because, you know, you might automatically think, oh, the inside is u, right? U is x squared plus 1, but, you know, when you get the derivative of that, that's going to be 2x, and you have extra x's there. But then, since, you know, you have experience with this kind of madness, you plow through. You go, okay, well, du is 2x dx. I'm going to pick it anyways because sometimes that's how things happen. And so then you go, well, 2x dx, so you need a 2 here for sure, so then you put a 1/2 on the outside. And you have x to the 3rd, you need to borrow one of those x's. So let's say you know, you're just moving one. Instead of putting it right here, you're going to put the x over here. So you're going to turn this into x squared. Sounded like a seal. Sorry, my sound effects aren't very good. And so this 2x dx, this is equal to du. And then right here you have u. But then how do you get rid of this x squared? Well, you just did a problem kind of like this. Remember? You know, if you solve for, on this one, if u is equal to x squared plus 1, well, then that means that x squared is equal to u minus 1. This one's even easier than the one you just did. So that means this guy, x squared, is equal to u minus 1. Well, okay, so that means that this is equal to 1/2 the integral of u minus 1 times the square root of u times that right there is du. So then to do this one, well, you can simply distribute that square root of u inside and simplify it. So this is going to equal to 1/2 the integral of u to the 3/2 minus u to the 1/2 du. So this is equal to u 3/2 plus 1, that's 5/2, and then times 2/5, which means that, what am I doing? Okay, sorry. I'm just going to do it step by step. So 2/5, the 1/2 is on the outside. You know, sometimes I just get ahead of myself. Anyways, so 1/2, you add 1, so that's 3/2, and then times 2/3. And that's it, right? Oh, plus c, don't forget. Okay. All right, anyways. So then what we get is we distribute the 1/2. And so that means that, and then I swap the u's for what it equals to, x squared plus 1. So that means I get x squared plus 1 to the 5/2 over 5 minus x squared plus 1 to the 3/2 over 3. And that's it. Nice work there, team. Nice work. You get a smiley face.